In the past, teaching periodic trends was a very short, sweet discussion to have with your students. It was simply know your corners, this one goes up, this one goes down, and away we go. But this only gives the students surface knowledge of the periodic trends. There are a few activities within the A+ College Ready materials that let the student explore the trends and explore the data and make decisions based on that data. You see 6 decks of cards. Each deck is the same. It just comes in different colors so you can keep one set separate from the other. So I will move these 6 out of the way. So the instructions for the students are to put them in a group. That group is responsible for sorting the cards. The pre-lab questions basically ask the students to define each trend. So there's ionization energy and electronegativity, etc. So that's what they're doing pre-lab, so they have an idea of what each one is. In the instructions, there's this listing of what each number on the card means. Students will have a reference of what each number means, and then the students are just put out, how should we arrange these? They're supposed to discuss, how should we arrange these? Should we do it on this upper right-hand number? Should we do it on this top left number? Which one should we do? So they have to have discussions about what's the right way to arrange them. And here's the big thing. There is no one right way to arrange these. The students can arrange them in a way that makes sense to them. So just like Mendeleev's periodic table was different from the modern day periodic table, it worked for him and ours works for us, but the student should feel free to find one that works for them. Also notice in the instructions, there's a card that says missing element. So there is a missing element out there, just like Mendeleev's original periodic table left gaps for elements that were missing. There is a missing element within the cards so students can try and figure out, what kind of element would that be? What are the properties of each one? Now I will warn you, this activity and the other activity called, why do they call it a periodic table, can be quite hard for the students to do. So you need to be willing to come by and give them a little bit of nudge and give them a little bit of help. Sometimes in groups, one person's very quiet and one person is doing everything. And again, maybe you need to farm out jobs of you're recording data, you're responsible for organizing so that everyone is actively learning. When the kid comes over and says, I don't know, again, we want there to be that productive struggle. So if they don't know what to do, here's HX, here's HX, here's XH, here's XH, here's XH2, and nothing, what am I supposed to do with this? This is where you as a teacher get to ask probing questions. Well, what do you think that means? By giving them that little bit of a nudge, they'll have some idea of how to proceed. It's okay to get things wrong as long as we're working towards being overall right. So this is one sample arrangement of how I've used the upper right-hand number, which is atomic radius, to group all the cards together. If the student had this, then you might call out, okay, why is that one there? Maybe they have a reason. We want to avoid saying that one doesn't go there, and instead saying, it seems like it's slightly out of trend. Would it be better to have the 0.083 come before the 0.10? And then between the two 0.10s, how are you going to decide which one goes where? This is what the student activity sheet looks like. It's got an introduction. It tells them what cards they need. Tells them what to do. And then this is how they laid out their cards. They should design what the energy, atomic radius, etc. of the missing element is. And then finally, they choose some of the data that's on the cards and they graph that data just like we've done for years and years.